Hello, welcome to Productions MJC. I had some complaints that my intro was too long and boring and didn't really get into doing anything until 38 seconds. Let's just kick it off and start out with this experiment to see if the sun and an application on your phone can help you determine whether the Earth is a globe or if the Earth is flat. The following video does contain references to applications used on the Android phone. The application is not out or available in the Apple iOS store. There are no sponsors, Google, Android, Apple, or the websites that will be referenced. Now, with that happy horse crap out of the way, let's get down to learning. If we honestly want to learn, how can we use our phone to help us do that? Of all places, I learned about this Android app in a Flat Earth discussion group. One flat earther in particular named Nikolas, I listened to what he was saying, and he said he was going to conduct an experiment to make observations of the sun and prove the flat Earth. And apparently there is an Apple app that can be used as a theodolite. Therefore, this isn't limited to just Android users, which is nice. I don't know exactly how to use these applications. I just did some rudimentary things with them because I'm no surveyor. I don't know what's going on. And while listening to these people and paying attention to the debate going back and forth, I had it confirmed to me that they were probably going to go about this the wrong way. Sure enough, one of the users put up this and it tried to explain that one was in Atlanta, one was in Kent, Washington, and they did this calculation and wanted to solve for X. Meaning, basically, he was claiming the sun was between Atlanta, which is C, and Kent, which is B, solving for X by creating two right triangles. Unfortunately, this assumes two incorrect things. It automatically assumes that the bottom of the triangle, BDC, is a perfectly flat line. It furthermore assumes that the sun at point A is somewhere in a direct line between Atlanta and Kent, Washington, and perpendicular to the ground. Then using trigonometry and Pythagorean theorem to further divide it into two right angle triangles, and then from there deduce how high the sun is for each observer. Actually, though, accidentally or intentionally, they forgot one thing. The closest that the sun ever got to Atlanta was between June 20th and June 22nd at the Tropic of Cancer, which is marked in the yellow line. Kind of close to Atlanta, but absolutely nowhere near Kent, Washington. Looking at this map, where we have Salt Lake City, Utah, and Atlanta, Georgia, you can see that the sun comes nowhere near being in a direct line between Atlanta, Georgia, and Kent, Washington. That obviously invalidates this idea, so what do we do about it? It assumes the ground is a flat Earth to begin with. That's not a way to conduct proper research, is to automatically assume your idea is right and then develop a test or proof of it. If you really want to find out, is it flat or is it round, that test needs to be done a lot differently. But hold on to the right angle concept, because that is helpful. The right angle, right triangle is helpful. There are even websites that you can take your information, plug it in, and you can solve and you can figure out what's going on. You don't have to do it all on your own. And let's examine what do we need to do then. Let's start our experiment and figure it out. First on the list, first and foremost, what is the sun doing? What is the sun doing right now? As I mentioned before, that red line is actually where the sun's at, because the Tropic of Cancer is represented by the yellow line and the blue line down below is the equator. The sun has started moving back towards the equator. The data gathered for the experiment happened on July 15th, and the sun was approximately at 17.11 degrees north. On its trip that day, the sun nearly passed directly over Belize, Guatemala. Using information garnered directly from the app on the Android phone and then uploaded to the Facebook discussion group, I am able to extrapolate that information and bring that to you right now. Unfortunately for them, the Facebook users forgot one glaring, obvious right angle, right triangle. The one where the sun is perpendicular to the surface of the Earth. Whether flat or a globe, we can use that right angle, right triangle in our calculations. And it's there free for the taking because it works on both representations and it can't be denied by either side. It works for both. We can get into some really heavy-handed stuff about calculating the distance between cities and all that stuff, the ones that are used, but nobody's going to believe that stuff. Let's keep it simple, so let's work with this. And there is somebody that has gone to a lot of work to calculate the difference in the flat Earth side or the globe side between distances. I did start out using these figures and everything else from the website. I quickly realized though that the figures are only 10% different, 3% different sometimes, depending on where, so I didn't use them that much. Using the information gathered from the uploaded pictures on the Facebook discussion group, we have Kent, Washington, well, somewhere near Kent, somewhere near Salt Lake City, somewhere between Atlanta and Athens, and we have somewhere between Turku and Helsinki, Finland, which was pretty easy to map out because it was flat out 45 degrees southwest. Boom, there you go. We'll call this Atlanta. Then we have also Salt Lake City and Kent, Washington up in the corner on the other side. So we have 4 different angles to the sun. No, they weren't shot at exactly the same time. They were different times of the day. They don't have to all be within milliseconds of each other because we have a constant, which is that right angle to the sun, demonstrated by that last line, Athens to Belize, Guatemala. The participants in the original preliminary gathering of information, those in Kent, Washington, and in Georgia, they have their information close. There was someone in Finland that was close to the first of that, having made a recording of the information, basically a screenshot, prior to, beforehand, just a bit before the call for the information. I, on the other hand, happen to know just about these 3, the Salt Lake, the Georgia, and the Finland. I didn't know about the Kent, Washington until later, but added that data in anyway. Blindly adding it in, however, it did add to the conclusions that were arrived in the midst of this experimentation. The information and data from screenshots was taken, plugged into a calculator, an online calculator, that calculated the various information for us, because keeping in mind it's a right angle, right triangle, so you simply plug in the distance that the city is from the path of the sun, and the path of the sun is at a right angle to the ground. Using the Atlanta, Georgia sample, we simply plug in the angle of degrees shown in the applications and the distance that we know, and we arrive at A is 4,658 miles above the ground. We have a right triangle with a base of 2242 miles, an angle up to the sun of 64.3. Now we have our first data point. Let's go to the next data point. Let's go to Salt Lake City and try this same thing. We'll do the same thing. We'll use the distance, the angles. We'll go to where we're actually looking at the sun, where the sun is perpendicular to the surface of the Earth. Same right triangle calculation, same right angle usage. We'll of course save Finland for last. Let's take a look at the calculations for Salt Lake City. Let's get to it. There were actually 2 screenshots. One was a little low, one was a little high, and it averaged out to be 51.5 degrees. Plugging these figures in exactly the same way the Atlanta, Georgia was done, it's only 3,000 miles high, 3070, and whoa, oh no, the other one was 1,600 miles higher? Wow, that's quite a difference, isn't it? Could this be a calculation error? What's going on? Let's take a look at some of the other information, some of the other data points. To be fair, Kent, Washington, and Atlanta, Georgia were the ones that started this. Let's look at the Kent data set. Okay, mileage 4099. and 49.4. So let's plug those in. Okay, that looks like 150 miles difference because this is 4782. And we just so happen to have another reading from Atlanta. So we've got two data sets from the same city. Let's look at that. Okay, we have the angle there, we have the mileage, so let's pop that into our little calculator and find out. And holy cow, that comes out to be almost 5,000 miles. That's a 400-mile difference almost from the first reading. Between this reading later and this reading earlier, we have quite a difference, don't we? Of course, now we have to turn to the Finland data set. Let's take a look at that. The information from Finland is pretty straightforward. We go back to, just looking at, it's basically a 45-degree angle is what the screenshot was telling us. Let's get the angle off of that screenshot. Okay, 11.5 degrees. Let's plug that into our little calculator, the mileage and the angle. Lo and behold, that is quite telling. It says the sun is only 900 miles high. The originator of this experiment originally only wanted to put in just one data set. Why would that be? With any research, the more data points you can get, the more information you can get, the more accurate your readings and information and end results of deductions are going to be. Unfortunately for flat earthers, the only thing you can deduce is this is not the way reality is. It just basically is not correct. A right angle over a flat plane will not produce varying heights like we just saw. Right angles don't lie. Math is an exact science. This convoluted way of a day and night cycle making the observations of the sun, not time zones, but actual solar observations, congruent with reality is just laughable. Right angles don't lie, people. Thank you so much for watching. I hope you enjoyed that. Please like and subscribe. Have a good day. This has been Productions MJC. For those of you who will say, hold on, flat earthers aren't going to accept that, of course they won't, because Bob Nodell didn't even accept his own experiment. He bought and paid for a fiber optic gyroscope, and his words, and I quote, were, "We obviously weren't going to accept that." It was his own experiment. Are they going to accept my experiment? No. They're not going to accept what I have to say because they don't even believe themselves when they prove it's a globe.